Welcome to unit number 4, topic 3, measures of dispersion. Measures of dispersion means standard deviation and coefficient of variation. Dispersion means range, the range of the data. Now in the previous example, we have found that the lowest age is 25 and the highest value is 35. The range is 10. Range means the difference between the lowest and the highest value. We can say there are 10 observations with an average of 30 and ranging between 25 to 35. What is the measurement of deviation? Deviation means the range. How to represent this range? Statisticians have discovered a technique or a tool that is called standard deviation. And standard deviation is the best measure of the range or the deviation. Now, how to calculate this standard deviation? There is one formula, square root of sigma x minus x dash square divided by n minus 2, which means square root of the squared differences of all the observation from the mean divided by the total observation minus 1. So applying this formula in this example, we can find that the mean is 30. Even if it is 30.3, we just take 30 for the convenience. And see x minus x dash, you can see in the third column, x minus x dash, the first value is minus 5. X means 25, observation. X dash means 30, that is the average. 25 minus 30 means minus 5. Similarly, 26 minus 30 is equal to negative 4. 27 minus 30 is equal to negative 3. 28 minus 30 is equal to negative 2. 30 minus 30, that is 0. 32 minus 30, 2. 33 minus 30, 3. 33 minus 30, again 3. The ninth value, 34 minus 30, 4. Then 10th value, 35 minus 30, that is 5. So that is the differences of each observation from the mean. Now we have to find the square of each value. So negative 5 square is equal to 25. The negative into negative become positive. The square of negative 4 is 16, square of negative 3 is 9, square of negative 2 is 4, square of 0 is 0, then 2 square is 4, 3 square is 9, 3 square is 9, 4 square is 16 and 5 square is 25, and the sigma, the sum total of all these differences is 117. Now in the formula, so it is square root of 117 divided by 9, that is 13, and square root of 13 is 3.6, and 3.6 is the standard deviation. What does it mean? Standard deviation means the standardized distance of all the observation from the mean, or we can say the average distance of all the observation from the mean. So by using the standard deviation, we can explain this data as there are 10 observation or there are 10 people with an average of 30 years of age with a standard deviation of 3.6, which means 90% of the observation fall within the range of 3.6. from the mean, which means 30 plus 3.6, 30 minus 3.6. Between these two values, majority of the observation fall. There is another rule called 2 standard deviation. 3.6 is the standard deviation. 2 standard deviation means 3.6 plus 3.6, that is 7.2. So 30 plus minus 7.2, 99% of the observation will be within this range. In this case, we can find 30 minus 7.2, which means 22.5, 30 plus 7.2, that is 37.5. You see 100% of the observation are within the range of 2 standard deviation. Now, what is coefficient of variation? Coefficient of variation or the standard error is the estimated standard deviation of all the sample means from a specific population. Now you find this is a sample of 10 observation. Suppose we take our class as the population which has 108 students. If we take 10 samples of 10 observation, we might get 10 different means. Now, putting all this mean into a table, and if we calculate the standard deviation of all the sample means, that is called the coefficient of variation. Now there is one statistical procedure to estimate this coefficient of variation, in other words the standard error. It is standard deviation divided by square root of n. Now standard deviation in this example is 3.6 and total number of observation is 10. Therefore standard error is 3.6 divided by square root of 10, which means 3.16, and the value is 1.14. This is called the standard error, or we can say this is the coefficient of variation, or we can say if we take all the possible means from a population, the standard deviation of all these means will be 1.14. Students, welcome to unit number 4, topic for measures of correlation. Measure of correlation means coefficient of correlation. The meaning of measures of correlation: it ascertains whether a change in one variable is associated with a change in another variable. So correlation is used to estimate the strength of relationship between two variables. For example, whether the higher income of parents is associated with high expectations of children in respect of the salaries and the job they will subsequently take up. Or if the lower income of the parents is correlated with the lower expectation of the children with regard to salaries and job they expect to take up. So there are two variables. One is the income status of the parents. The second variable is the expectation of the students. There is likelihood that it is related to each other. So what is the strength of this relationship? So in order to understand this relationship, we use the measure of correlation. So coefficient of correlation is a number which is between +1 to -1. The coefficient of correlation changes in value from +1 down through 0 to -1. So coefficient of correlation ranges from 1 to 0. So we have 4 levels of correlation. The value is between 1 to 0.7, we can say there is high correlation. If the value is between 0.7 to 0.4, there is substantial correlation. The values between 0.4 to 0.2, there is low correlation. And the values below 0.2, it is negligible correlation. And there is positive correlation and negative correlation. Positive means a positive change in one variable affects positively the other variable. Which means higher the income of the parents, higher the expectation of the students. Now, negative correlation means higher the value of one variable, lower the value of another variable. For example, income and the crime rate. Higher the income, lower the crime rate. Lower the income, higher the crime rate. But this is just a hypothesis. It may not be true everywhere. Just for example, I have mentioned this. Now, here we have an example, age and attitude score. The column number 1 you find age of the respondent, and the second column attitude score. And we can find out the correlation between age and attitude. Whether there is any relationship between age of the respondent and the type of attitude he or she holds. We will use SPSS to estimate the correlation coefficient, which I will be explaining later. There is use of SPSS for various statistical procedure. So the calculation of correlation coefficient will be explained along with SPSS.